everybody. Today we're going to be talking about our Pythagorean identities and where they come from. So we're going to be talking about tan theta equaling sine theta over cosine theta, our cotangent theta equaling cosine theta over sine theta, our sine squared plus cosine squared theta equaling 1, then our tan squared theta plus 1 equaling secant squared theta, and our cotangent squared theta plus 1 equaling cosecant squared theta. So where do all these come from? Well, first we're going to want to draw a unit circle. And here, let me draw a unit circle. Okay, and then go ahead and make it move it around a little bit. There we go. Probably going to make it a little bit bigger just because. Yeah, that's good. Okay, and we know that our unit circle has a radius of 1, because x squared plus y squared equals 1. This would be our r squared. Square root of 1 is 1, and that's our unit circle. There we go. And then right there. Okay, that is our unit circle. Now, what we know from this is we can take any angle theta. I made that a little big. Let's draw a line here, okay? So this is our theta, right? We know r is equal to 1 right here. This is our x value, and this is our y value. Now we can figure out our sine from our SOHCAHTOA. And this stands for opposite over hypotenuse. This stands for adjacent over hypotenuse, and this stands for opposite over adjacent. So our sine value is going to be our opposite angle, which would be the y value, so y over 1, which simplifies to just y. So the sine is going to be the y value. The y value, sine theta, is equal to the y value. Now our cosine theta is equal to our adjacent over our hypotenuse. So this is x over 1, which, oh wow, look, it's just x. And now our tangent function is going to be defined as our opposite over our adjacent. The opposite angle is going to be y over x. So y over x, hey, wait a minute, y over x, that's our sine over our cosine. So sine theta over cos theta is equal to tan theta. Alright, so now we got that one out of the way. Let me clear this up a bit. Okay, now, let me just draw a little check next to that one, show we've done that. Now our cotangent theta is just our 1 over tan theta. So we can show this, we can substitute 1 over sine theta over cosine theta. And you know we can just do division as multiplication with the reciprocal. So 1 times cosine of theta over sine of theta. And look at that. Get rid of that 1. And we just have a nice pretty cosine theta over sine theta. There we go. And right now is where I am wishing I had our unit circle back to show this. So let me just draw that again real quick. So sine squared plus cosine squared equals 1. Where can that come from? Oh wait, look, we already defined our x as cosine theta and our y as sine theta. So what we can do right here is we can check this equation and realize that this right here is our y, right? Our y, so y squared plus x squared. Because these are our sides, we're using our Pythagorean theorem because this is a right triangle. A squared plus b squared equals c squared equals 1 squared, right? We could substitute this with, y should be sine squared theta plus cosine squared theta equals 1 squared is just 1. So there we go. Okay, now we have these last two, and these last two are going to be very simple. I don't need to draw anything or show anything. But what we're going to do is we're going to take this original function, because this is kind of like the GOAT of any trig identities. So what we could do is we can take sine squared theta plus cosine squared theta and equal it to 1. And what we're going to do is we're going to divide this first by cosine squared of theta. Cos squared of theta. And we can do this because we're doing it to both sides. Cos squared theta. Yeah. And divide this by cos squared. Let's get 3 theta. What we're going to do here is we're going to see this right here. Since this is just our tangent squared, we're going to get tan squared theta over cosine squared is going to just be 1 equals 1 over cosine squared. Remember that secant is our reciprocal to cosine, so we have secant squared theta. And now, similarly, we're going to do this with our sine. We're going to divide by sine. And here we go. So divide by sine squared theta, sine squared theta, and sine squared theta. We're going to get 1 plus cotangent squared theta, because it's our reciprocal to tangent. And this is going to be our cosecant squared theta right here. And rearrange cot squared plus 1 equals cosecant squared theta. Now, if you want to stick around, you can see some practice problems we can do with these that are going to come up. So if you want to click off now, you know all these identities. Cool. If you want to do some practice problems, stick around. Okay, our first problem is going to be simplifying this. So this right here is our thing. So first what I want to do is I want to get rid of all of these tangents and secants. I want to get everything in terms of sine and cosine. So we can do 1 over cosine theta times sine theta. And since we're going to do the reciprocal, we're going to multiply by cotangent, which we're going to rewrite actually as cosine over sine. So cosine theta over sine theta. And now you're going to see that we can start canceling things out. So we can just rewrite this all on one line as sine theta cosine theta over sine theta cosine theta. And you're going to see that these cancel out and lead us to getting our answer of 1. Our next function right here is going to be cosine theta times tan theta. And it's nice because we have cosine and a tangent, and we can just get everything in terms of cosine and sine really quickly. So cosine, we're going to leave like that, times sine theta over cosine theta. And we know these are going to cross out, and the answer is just going to be sine theta. Very simple. Now, here we have a secant, a tangent, so we're just going to get everything in terms of sine and cosine. Sine theta times tangent is going to be sine squared over cosine. And these have like terms at the denominator, so we can combine these as to 1 minus sine squared theta over cosine, sorry, not squared, we're not squaring this one. And what we're going to do is we're going to remember that our sine squared theta plus cosine squared theta is equal to 1, and we're going to rearrange this a little bit. So what we're going to do is we're going to subtract sine squared theta, and we're going to get is cosine squared theta is actually equal to this expression right here. So cosine squared theta over cosine theta is just going to be our cosine of theta. That looks terrible. I'm sorry about that. Our cosine of theta. Here's our next function right here. So we have sine theta times tangent theta is equal to cosine theta. And by now we know we're going to convert tangent in terms of sine and cosine. So we're going to get sine squared of theta, because sine times sine, sine squared, cosine of theta plus cosine of theta. Now what we're going to do here is we're going to do a little bit of algebraic manipulation, where what we're going to be able to do is we're going to be able to multiply this entire expression by cosine theta over cosine theta. And we're able to do this because cosine of theta is the same as cosine of theta. Denominator and numerator denominator are exactly the same, so it's going to be 1. We're multiplying it by 1 effectively. So we're going to get cosine squared, sorry, not squared, cosine theta sine squared theta over cosine squared theta plus cosine, I'm just going to leave that as cosine for the time being. And we're going to be able to do is we're going to be able to pull this cosine theta out. Sine theta over sine squared theta over cosine squared theta is going to be equal to tan squared theta plus cosine right here. And what we're going to be able to do is we're going to be able to factor out this cosine theta. So we're going to get cosine theta times tan squared theta plus 1. And as we know, our tan squared plus 1 identity is secant squared theta. And we're going to multiply this by cosine squared theta. And since we know these are reciprocals, we can rewrite this as 1 over cos squared theta. Cosine times 1 over cosine squared theta is going to be 1 over cosine theta, which is also equal to secant theta, and that is how we find the answer. Now this function right here after the last one should be very easy because we just used this identity. Tan squared plus 1 is equal to secant squared theta times cosine of theta, and we're going to get the exact same answer as before. So we're going to get 1 over cosine theta or secant theta. Now right here, you should also be seeing that because this tan squared theta plus 1, you should be noticing a pattern. This is going to be 1 over our secant squared of theta, which is our reciprocal function of cosine, so we can also just rewrite this as cosine squared of theta. This one right here, we're going to have to use our identity for cotangent, which is cosine theta over sine theta times secant, but we're going to rewrite that as 1 over cosine theta. And you should be noticing that this is very simple. We're going to cross these out, and we're going to get 1 over sine theta, which is equal to our cosecant theta. This one right here is also going to use our sine squared plus cosine squared equals 1 identity, right? If we rearrange, we can get cosine squared theta to equal 1 minus sine squared theta. So we can rewrite this as cosine squared theta times secant squared theta. And because this one's a reciprocal of that, when you multiply this out, it is going to equal 1. And if you don't know where that comes from, because secant squared is really just 1 over cos squared. And multiply that by cosine, you're going to get cosine squared over cosine squared, which is 1. Now for this one, it's going to be tackled a little bit differently because we're going to have to do a little bit of factoring. We're going to have to remember that our cos squared theta is equal to our 1 minus sine squared theta. So we're going to write that as 1 minus sine squared theta over 1 minus sine theta. And you may be tempted to cross out now, but you cannot do that because they are not factors of each other. So we're going to have to factor the top part out. We're going to get 1 minus sine multiplied by 1 plus sine, because it is a difference of squares, over our 1 minus sine function. Cross these out. So our answer is going to be 1 plus sine theta. Now for this function, you may be tempted to look at this and think of something other than distributing, but really all you want to do is just distribute this. So we know that sine and cosecant are reciprocals, because cosecant is equal to 1 over sine. So we're going to multiply that, and we're going to get 1 minus, and then we're going to get sine times sine. We're going to get sine squared of theta. From our Pythagorean identity, we are going to get cosine squared theta. That is our answer. For this one, we're going to do something a little bit differently first. We're going to recall one of our identities. So we're going to find cotangent squared theta plus 1 is equal to our cosecant squared theta. So you may be wondering, what are we going to do here? So what we're going to do is we're going to bring the cosecant to the other side and make it negative, and we're going to bring the 1 over to the other side and make it negative. So what we're going to do is get cotangent squared, and we're cotangent staying there, plus, minus cosecant squared theta equals negative 1. And hey, look, that's exactly what we have up here. These are equal. So we're going to take the answer to that, and we're going to get negative 1. Last but not least, we have our tan theta times cosecant theta. And this one's going to be a little bit easier than the other ones. So our tan, we're just going to rewrite it just for why not, times our 1 over sine theta. And these are going to cross out. We're going to get 1 over cosine theta. And what is that equal to? That is equal to our secant theta. Now, after watching this video, I hope you understand all of these functions, where they come from, and how to use them and apply them in certain scenarios. And if you have any questions, drop them below in the comment section, and I will try to answer them. Make sure to like and subscribe. It'll help me out a lot, and have a good day.